We've been taught since grade school that if we have a fraction times a fraction, we multiply across the top and we multiply across the bottom and we get our result. But why is that the case? And I want to illustrate that to you. So let's think about the principle that I'm going to use to show this. Now, to prove fraction multiplication, I can't use fraction multiplication, or at least not this method. So I'm going to use another one so that it doesn't end up being circular reasoning. And so think about this. When you multiply something by a fraction, it multiplies into the top always. 3 times 2 sevenths is the same thing as 2 sevenths plus 2 sevenths plus 2 sevenths. So it would be 6 sevenths, but we're getting that 6 by tripling the 2 that was there, and we get 6 sevenths. The numerator is where all the action takes place, the addition or the multiplication. It's important to remember the bottom of a fraction, the denominator, is nothing more than the units we're dealing with. They're just kind of passive. What if we have a fraction times a fraction? Well, it's the same thing. This is a multiplier and it multiplies into the top. So here I've done that. I multiplied it into the top, and 1/2 times 2 is the same as 1/2 of 2, which is 1, and we get what we expected, that half of 2 sevenths is 1 seventh. So it doesn't matter if it's a fraction or an integer, multiplication goes into the top of a fraction. It multiplies the numerator. Let's look at a case with numbers. So I have 2/3 times 4/5, and I'm going to get to here without actually doing the typical fraction multiplication, using only the principle of multipliers going into the top. So if I have this times this, well, my multiplier is going to go into the top. Well, we've seen that a multiplier, again, we see it over and over, it's going to go into the top. So that's what I have here. So this is where we are so far. But I don't want a fraction in my fraction. Here I have a little fraction in the big fraction. And so I want to kill this fraction. And the way we can do that is use the principle that I'm sure you probably remember. I can take any fraction in the world, and if I choose to multiply the top and the bottom by the same thing, I'm okay. I'm just scaling the whole fraction up by a factor of 5, but it's going to give me the same thing. It gives me 5/10, which is the same thing as 1/2, which is what I started with. So I can multiply the top of a fraction by anything I want as long as I multiply the bottom as well. So what I did was I took this fraction and I multiplied the top and bottom by 3. And so now again the 3 is going to go into the top. That's what I have here. But now I can cancel the 3's because 3 over 3 is just 1. It's the same thing as 1 times 2 times 4. And that's what we have here. And we have the result that we have a fraction times a fraction, and essentially the tops multiply and the bottoms multiply. Now, using numbers is not generally the way we do proofs, because it really only proves it rigorously for that one case, this fraction times this fraction. If we want to be general and prove it that it works for all numbers, we have to use variables. So this stands for any fraction times any fraction, and we're going to get from here to here. And I'm going to do the same thing I did with the numbers. I'm going to call this the multiplier. It's going to multiply into the top of this fraction. So we're up to here. Then this variable is going to go into the top. And so that gets us up to here. But now I want to kill the fraction. So I'm going to multiply the top and bottom of this fraction by b. And so that's what I've done here. So that allows me to, well, first, I'm putting like steps in here that weren't really necessary, but I'm trying to be really explicit and clear. So here we see the b in the top of the fraction, again using the same principle over and over, that the multipliers multiply into the top. Now I can cancel that b, and there we go. We have a times c over b times d. So we have illustrated that if we multiply across the top and across the bottom, that is a valid result. Just as a closing note, it's kind of worth, I'm going to make up something here, it's kind of worth mentioning that when you have a fraction times something, I'm just going to make up another fraction here. The top of the fraction multiplies whatever is the recipient of the multiplication, the object, and the bottom divides. So we've already seen that this will double this fraction, but the 3, if we take 5/7 and multiply it by 3, it's going to make the bottom 3 times as big, which means the fraction is 3 times as small. So if you ever want to divide a fraction, then, so 4, I don't know, let's say 4/12. If you want to divide this by 3, just put a 3 in the bottom. So that's really kind of the big picture of what's going on here. That's why this, as the divisor, could just go straight into here instead of doing all these gymnastics to get to this.